Hi class. Now I'm going to present you a few, four to be exact, a few examples of hypotheses that would require a one-tailed test in order to test. So there are four hypotheses that I've labeled example D, E, F, and G. I will read the set of hypotheses and then I will show you, after I read a set, I'll show you how the probability distribution would be set up. And again, you're going to need to know how to how to set up the drawing in order to conduct the test. So here's example D. H sub 1, the research hypothesis. H sub 1. 6th grade Boy Scouts will spend significantly more days camping per month than the population of 6th grade boys. The population mean is 0.2 days, 0.2 days. Again, the research hypothesis, 6th grade Boy Scouts will spend significantly more days camping per month than the population of 6th grade boys. Population mean equals 0.2. The null hypothesis, H sub 0, is 6th grade Boy Scouts will not spend significantly more days camping per month as the population of 6th grade boys. Population mean is 0.2 days per month. Again, null hypothesis. 6th grade boys will not spend significantly more days camping per month as the population of 6th grade boys. If we were at, well, first of all, I can tell you right away, and hopefully you can too, that those hypotheses would require a one-tailed test in order to investigate. The reason is because the hypotheses state direction. In this case, the word that states direction is more than. 6th grade Boy Scouts spend more days camping than the population. So we need a one-tailed test because direction is stated. This is what the probability distribution would look like if we were to set up this problem and if we were asked to test the null hypothesis at the 0.05 level. Again, that is area, that is space, that is the size of the critical region or the rejection region. So setting this up, as you can see, this is different from previous examples because there's only one tail. We've been asked to test this hypothesis at the 0.05 level. That's the size of the tail, 0.05. That means that this piece has to be 0.95. 0.95 plus 0.05 is 1. 0.05. Let's do another one. Example E. Accountants have significantly fewer nightmares per week than the total population. Population mean is 0.4 nightmares per week. That's H sub 1, the research hypothesis. Accountants. Accountants have significantly fewer nightmares per week than the total population of 0.4 nightmares per week. H sub 0, the null hypothesis. Accountants will not have significantly fewer nightmares per week than the total population mean of 0.4 nightmares. So once again, we have a situation where we need a one-tailed test because direction is stated in the hypotheses via the word fewer. How would that distribute? How would the probability distribution look if we were to test this? Well, let's assume that we are testing the null hypothesis at the 0.01 level. The first thing I hope you notice is that we do indeed have a one-tailed test. The entire critical region is in one side of the distribution. However, because the hypothesis says fewer, lesser, the tail is only on one side and it is the left side of the distribution. In the first example that I gave in this segment, right here, the critical region or rejection region or tail is also in one side, but because The hypothesis said more days camping, more. That means that the critical region or the tail, the rejection region, is on the right, is in one tail, and it's on the right side. In this instance, we are comparing a sample accountants to the general population regarding how many nightmares they have per week. And the hypothesis is accountants have significantly fewer nightmares per week than the total population mean. Fewer nightmares. One tail on the left side, not the right side, the left side, because we said fewer. Also, the critical region size is 0.01, so we put that here, 0.01. Also, since this piece, and we only have 2 pieces instead of 3, since this piece is 0.01, I know that this piece has to be 0.99. 0.01 plus 0.99 equals 1. The total area under the entire curve is 1 expressed as a proportion, or 100% expressed as a percentage. Let's do example F. Example F. H sub 1, research hypothesis. UMKC engineering majors take significantly more math credits than all U.S. engineering majors, and the population mean is 24 math credits. The null hypothesis, H sub 0, UMKC engineering majors will not take significantly more math credits than all U.S. engineering majors, population mean 24 math credits. So again, we have a situation where we need a t-test for one sample. Our sample is UMKC engineering majors. That's our sample. We want to compare UMKC engineering majors to the entire population of engineering majors regarding how many math credit hours. And our hypothesis again states, our research hypothesis states that UMKC engineering majors take significantly more. We need a one-tailed test. One-tailed test because direction is stated. Let's assume we're testing this hypothesis, or that we were asked to test this hypothesis at the 0.025 level. That's the size of the tail, size of the critical region, size of the rejection region. I place that here. I've got one tail on the right side. Why is it on the right side? Because the hypothesis says more math credit hours, right? If I know this piece is 0.025, I know this piece has to be 0.975. 0.975 plus 0.025 is 1, or 100%. So you can see that these hypotheses are requiring one tail, but the side, left or right side of the tail, depends on how the hypothesis is worded. Let's do example G. H sub 1, research hypothesis. UMKC anthropology majors will take significantly less time to solve a puzzle than all UMKC students. The population mean is 38 minutes. Null hypothesis, H sub 0. UMKC anthropology majors will not take significantly less time to solve a puzzle as all UMKC students. So again, we have a set of hypotheses that needs a t-test for one sample. We have one sample, in this case anthropology majors, and we're going to compare them regarding the amount of time it takes them to put a puzzle together to a population. In this case, the population is defined as all UMKC students. UMKC anthro majors will take significantly less time to solve a puzzle than all UMKC students. Null hypothesis, H sub 0. UMKC anthropology majors will not take significantly less time. What would the probability distribution look like? Well, assume, if you will, that we're asked to test this hypothesis at the 0.005 level. Well, we know we need a one-tailed test. We know that tail is on the left side because the hypothesis says lesser amount of time, significantly less time. And if this piece, 0.005, the tail, the critical region, the rejection region, is 0.005, then I know that this larger piece has to be 0.995. 0.005 plus 0.995 is equal to 1. So a one-tailed test with a specific size, and when we have a one-tailed test situation, we have to know which side to place it on, and that comes from how the hypotheses are worded.